Welcome to these gentle, soothing stories for sleep. Tonight, we will begin a quiet and wondrous journey together, drifting back through the silent corridors of time to witness the very beginning of our universe. Let this story be a soft vessel to carry your mind away from the edges of your day and into the deep, peaceful expanse of the cosmos. Before we begin our descent into the starlight, I would love to know where you are listening from tonight, or perhaps just a word about how your day has been. Please feel free to leave a gentle thought in the comments below. And if these stories bring you comfort, please support this channel with a like and subscribe so that we may continue to share these journeys with you. Thank you so very much. And now, find a comfortable position, allow your eyes to gently close, and let your breath slow as we begin our story in the familiar, gentle darkness. The darkness that surrounds you now, the soft and quiet dark of your own room, feels like an ending, a gentle closing of the day, a curtain drawn across the world of light and sound. It is a personal darkness, a familiar and peaceful void into which we can safely let go. But this intimate stillness is just the smallest echo of a much older, much vaster darkness, the profound and silent canvas of the night sky upon which the entire story of our universe is written. And as your mind begins to drift, imagine yourself floating upward, through the ceiling, through the quiet night air, until the sounds of the world below become a faint and distant hum, and you are suspended in the cool, clear emptiness above. Here, the darkness is not an absence, but a presence, a deep and velvet stage set with 1,000,000,000,000 shimmering lights. Each point of light, each distant star, seems to appear to us in a single, shared instant, a collective and simultaneous twinkling. But this is a beautiful illusion, a gentle trick played by our perception. The truth is profoundly deeper, for the light from each star is on a journey, an ancient pilgrimage across the vastness of space, and it travels with a speed that is immense, yet finite. The universe has a speed limit, a cosmic constant known simply as c, approximately 300,000 kilometers per second, and nothing can travel faster. This light, the light that is now gently entering your mind's eye, is not instantaneous. It has been traveling for years, for centuries, for millennia, to reach you tonight. This journey of light gives us a way to measure the universe, not just in distance, but in time. We speak of a light year, and the name itself sounds like a measure of time, like a calendar for the cosmos. Yet, it is a measure of distance, the almost unimaginable distance that a single particle of light, a photon, will travel in one terrestrial year. It is a journey of nearly 9.5 trillion kilometers, a number so vast that it almost loses its meaning. But its true magic lies in its dual nature. Because the light has been traveling for so long, to look out at a star 1 light year away is to see that star not as it is today, but as it was 1 year ago. The starlight is a postcard from the past, and so, the simple, peaceful act of looking up at the night sky is, in fact, an act of time travel. You are not seeing the stars of tonight, you are seeing a collage of yesterdays. The closest star to our own sun, a small star called Proxima Centauri, is just over 4 light years away. The light you see from it tonight began its journey more than 4 years ago, perhaps while you were in a different home, a different job, a different season of your life. That faint, reddish glow carries no information of the star's present moment, only the story of its past, a story that has been whispering its way across the void, just to arrive here, with you, now. And as your gaze drifts further, you might find the North Star, Polaris, a beacon for travelers for centuries. Polaris is over 430 light years away. The light that graces our sky from it tonight set out on its journey around the year 1593. It is an echo from the time of Shakespeare and Galileo, a silent messenger that has been patiently crossing the immense, dark ocean of space throughout all of modern human history. While empires rose and fell, while generations were born and faded, while all of our art and science and love and loss played out on this tiny blue stage, that light was travelling, steadfast and silent, on a collision course with our future. And so, every star becomes a time capsule. The night sky is not a static photograph. It is a museum of ancient artifacts, a library of luminous histories. Some lights are from last year, others from the last millennium, and some from much, much further still. The deeper you look into space, the further you are peering into the past. You are looking at a history book whose pages are written in fire and distance. The universe is revealing its own autobiography to you, and it asks only for your quiet attention. And as you float here, in the peaceful emptiness, surrounded by these gentle ghosts of light, these echoes from a million different yesterdays, you begin to feel the true texture of time, not as a river flowing past you, but as a deep ocean in which you are suspended, with the past visible in every direction you turn. The entire sky is a vast and shimmering tapestry of time, a document of what once was. And within that luminous tapestry of time, there are woven structures of an even grander scale, patterns that emerge only when you allow your focus to soften, moving from the individual pinpricks of light to the soft, collective glow they form together. If you were to look up from a place far from the haze of city lights, you would see it. A faint, milky band of light stretching across the entire dome of the sky, a soft and ghostly river flowing through the constellations. Ancient cultures saw it as a pathway for souls, a celestial river, or the spilled milk of a goddess. We now know this gentle stream of light for what it truly is. A glimpse of our own home, seen from the inside. We are looking at the dense, star-filled plain of our own galaxy, the Milky Way. We are not outside observers looking in. We are residents of this vast, celestial city, looking across its glowing avenues from our quiet, suburban neighborhood. To see the Milky Way arching across the sky is to see the sheer, breathtaking scale of our immediate cosmic family. It is the visual proof that our sun, our Earth, our own existence, is part of something immeasurably larger. This city of stars, our Milky Way, is a barred spiral galaxy, a vast rotating disk of stars, gas, and dust. Imagine a colossal, pinwheeling firework, frozen in a moment of silent, slow-motion explosion. At its heart is a dense, brilliant core, a swarm of ancient stars packed tightly together, and from this core, several great arms spiral outwards, like the swirling tendrils of a celestial hurricane. These arms are the stellar nurseries, the places where brilliant, young, blue stars are born, illuminating the clouds of gas and dust around them. And we are nestled within one of these graceful, sweeping arms. Our cosmic address, if we were to write it down, would place us in what astronomers call the Orion Arm, a smaller, minor spiral arm located about 2/3 of the way out from the galactic center. We are not in the chaotic, crowded downtown, nor are we on the lonely, distant fringe. We reside in a peaceful, gentle region, a perfect place for a solar system like ours to quietly coalesce, and for life to have the chance to emerge undisturbed by the violent radiation of the galactic core, or the stark emptiness of the intergalactic void. There is a profound comfort in this sense of place, in knowing that our existence is not random but is situated, located within a grand and ordered structure. The sheer scale of this structure is a concept that the human mind can only approach through poetry and metaphor. From one edge to the other, the disk of the Milky Way spans over 100,000 light-years. To cross our galaxy at the speed of light, the fastest anything can travel, would take 100,000 years. The light from stars on the far side of our own galactic home began its journey towards us when our earliest human ancestors were first walking the Earth, and it is still only halfway here. And within this vast, flattened city, the number of fellow stars, the number of other suns, is estimated to be between 100 billion and 400 billion. Let that number gently settle in your mind. 400 billion stars. For every single human being who has ever lived, there are dozens of stars in our galaxy alone. It is a population so immense that it renders our own sun, the brilliant, life-giving center of our world, as just one ordinary citizen in a metropolis of dazzling, uncountable lights. It is a deeply humbling, yet strangely connecting thought. To know that our world is not unique in its basic components, but is part of a vast and shared family of stellar systems, each one a potential anchor for its own worlds, its own stories. And this entire, immense structure is not static. It is in constant, graceful motion. The entire galaxy is rotating, a slow and majestic celestial dance that takes place on timescales that defy our everyday comprehension. Our Sun, along with our entire solar system, is orbiting the center of the Milky Way at a speed of over 800,000 kilometers per hour. And yet, even at this incredible velocity, the distance is so vast that it takes us approximately 230 million years to complete a single orbit. The last time our Earth was in this same position in the galaxy, dinosaurs were just beginning to roam its surface. The time before that, the world was a primordial landscape of ferns and ancient insects. The galaxy keeps its own deep time, a slow and steady rhythm that underpins all of planetary and biological evolution. And so, you are not simply sitting still in a quiet room. You are a passenger on a planet, which is a passenger in a solar system, which is a passenger in a grand, spiraling arm, all of it turning in a silent cosmic lullaby that has been playing for billions of years. You are held, safely and gently, within the luminous, turning river of the Milky Way, a single, conscious note in its ancient, silent song. And this immense, silent structure, this city of 400 billion suns that holds you in its gentle, turning embrace, is itself built from the most humble and fundamental of materials. The stars that shimmer like distant diamonds are not, in their essence, complex. They are born from the simplest element of all, hydrogen, the first and most abundant atom in the universe, a single proton and a single electron. The great, dark clouds that drift in the spaces between the stars, the cosmic nurseries where new suns are waiting to be born, are made almost entirely of this primordial hydrogen and a little helium. And the story of how these simple beginnings were transformed into the rich, complex tapestry of the world we know, into the very substance of your own body, is the story of the stars themselves. It is a story of alchemy, carried out on a scale so vast it boggles the imagination. For every star is a furnace, a cosmic heart whose steady beating is the pulse of nuclear fusion. In the core of our Sun, and in the core of every star you see, the pressure is so immense and the temperature so high, millions of degrees, that the normal rules of matter are suspended. The gentle gravitational pull of the star's own mass creates a crucible of unimaginable force, squeezing the hydrogen atoms so tightly that they overcome their natural repulsion and merge, they fuse, into something new. In this fiery heart, hydrogen becomes helium, and in that transformation, a tiny amount of matter is converted into a tremendous burst of energy. The very light and heat that radiates outwards travels across the solar system and warms the face of our world. This process, stellar nucleosynthesis, is the engine of the cosmos. For billions of years, our Sun will steadily convert hydrogen into helium, a slow and stable fire. But in other, larger stars, the process continues. When the hydrogen runs out, the star begins to fuse helium into carbon, and then carbon into oxygen, and neon, and magnesium, and silicon. The star becomes a great, cosmic onion, with layers of successively heavier elements burning within it, each one forged in the ashes of the last. But this process has a limit. The fusion continues, creating ever heavier elements, until it reaches iron. Iron is a kind of cosmic dead end, a form of atomic ash from which no more energy can be extracted through fusion. For a truly massive star, a supergiant dozens of times more massive than our Sun, this moment marks the beginning of the end. Its heart, once a source of radiant energy, becomes a dense, inert ball of iron, and the delicate balance between the outward push of fusion and the inward pull of gravity is broken. In a fraction of a second, the star collapses under its own colossal weight, and then rebounds in the most spectacular event in the universe. A supernova explosion. This is not a death, but a transfiguration. It is the universe's most magnificent act of creation, a final, generous exhalation that blasts all of those precious, newly forged elements out into the cosmos with unimaginable force. In the final, fiery moments of the explosion itself, even heavier elements are created, elements that stellar fusion could never achieve, like silver and gold and uranium. These scattered ashes of ancient stars, this precious dust of carbon and oxygen and iron and gold, then drifts through the interstellar medium for millions of years. This stardust enriches the great, cold clouds of hydrogen gas, seeding them with the raw materials for complexity. The next generation of stars that forms from these clouds will have these heavier elements within them from the very beginning. And surrounding these new stars, disks of this enriched dust and gas will form, coalescing into planets and moons and asteroids. Our own sun is not a first-generation star. It is a child of the ashes of other stars that lived and died long before it was born. Our solar system was formed from one such enriched cloud, roughly 4.5 billion years ago. And so, the Earth itself, the ground beneath your feet, the air you breathe, the water that fills the oceans, is all composed of recycled stardust. And this cosmic heritage flows directly, intimately, into you. Take a slow, gentle breath. The oxygen that fills your lungs was forged in the heart of a star, hundreds of times larger than our sun. The carbon that forms the long, elegant chains of your DNA, the very blueprint of your existence, was created in a stellar furnace through the fusion of 3 helium atoms. The calcium that gives strength to your bones, the iron in your blood that carries that precious oxygen to every cell, all of it was created in the final, explosive moments of a dying star billions of years ago. You are not merely living on the Earth. You are a part of the Earth, and the Earth is a part of the cosmos. The universe is not something outside of you, a distant collection of lights in the sky. It is within you. You are, in the most literal and profound sense, the ashes of long-dead stars, a piece of the universe that has, for a brief and beautiful moment, woken up and begun to wonder where it came from. And yet, this cosmic dust, these scattered and precious ashes of ancient stars, do not simply drift alone forever in the cold and silent dark. They are gathered and sculpted by silent, unseen architects, by fundamental forces that operate ceaselessly and perfectly at every scale of existence. These forces are the invisible grammar of our universe, the deep and unchanging rules that allow for the formation of everything from a single atom to a swirling galaxy. There are 4 of these fundamental forces, 4 architects working in harmony to build the reality we experience. They are gravity, the great sculptor, electromagnetism, the messenger and the binder, and the 2 nuclear forces, strong and weak, the silent anchors that hold the heart of matter itself together. They are so woven into the fabric of our world that we rarely notice them, yet without their constant, gentle persuasion, the universe would be nothing but a thin, featureless soup of disconnected particles. These forces are the reason that anything, anywhere, can hold together and become something more than the sum of its parts. They are the source of all structure, all chemistry, all life. The first and most familiar of these architects is gravity. Of the 4 forces, it is by far the weakest, and yet its influence is the most far-reaching. Gravity is the patient, persistent artist of the cosmos. It was gravity that first coaxed the primordial clouds of hydrogen and helium to begin collapsing in on themselves, their growing density igniting the first stars and setting the universe ablaze with light. It is gravity that holds the hundreds of billions of stars in our Milky Way together, choreographing their slow, 200 million year dance around the galactic core. It is the force that gathered the dust of our early solar system into the planets we know today, and it is the force that holds our own moon in its gentle, loyal orbit. And it is, of course, the force that holds you, softly and securely, to the surface of this turning world. Gravity is a whisper that travels across the entire universe, a constant, gentle pull that matter exerts on all other matter. It is the universe's great organizing principle, the silent conductor of the cosmic symphony, ensuring that from chaos, order and structure can always emerge. The second great architect is electromagnetism, and if gravity is the sculptor, then electromagnetism is the force of connection, chemistry, and communication. On the scale of our daily lives, It is immensely more powerful than gravity, and it is the force that gives the world its substance and its color. It is the force that binds the negatively charged electrons in their beautiful, cloud-like orbits around the positively charged nucleus of an atom, and in doing so, it dictates all of chemistry. The way atoms bond to form molecules, the way water clings to itself, the very structure of the chair you are resting on, and the intricate, folded shapes of the proteins in your body are all governed by the dance of electromagnetism. It holds your own body together. But it does something more. This force is also responsible for light. The particles of light, photons, are the carriers of the electromagnetic force. And so, this single force is responsible for two miraculous things. It creates the structure of the world, and it also creates the means by which we can see that world. It is both the ink and the message, the sculpture and the light that illuminates it. Every star you see, every color you can imagine, is a message being delivered to you by this elegant and fundamental force. And beneath all of this, in the impossibly small and silent realm at the very heart of the atom, the final two architects perform their essential work. There is the strong nuclear force, the most powerful force in the universe over short distances. It is the unbreakable bond that holds the protons and neutrons together in the atomic nucleus, overcoming the immense electrical repulsion that would otherwise blast them apart. It is this force that keeps the atoms of your body stable, and it is the harnessing of this force that powers the stars themselves. It is the anchor of reality, the source of all atomic integrity. And finally, there is the weak nuclear force, a more subtle and mysterious player. It governs processes of transformation, like certain forms of radioactive decay, allowing one type of subatomic particle to change into another. It was the weak force that helped to convert protons into neutrons in the universe's first few minutes, allowing for the creation of helium, and it plays a crucial role in the chain of nuclear reactions inside our sun. It is the force of change, of subtle but essential alchemy. And so, as you rest here, these four forces are working in a silent, perfect harmony within you and all around you. Gravity holds you to the earth, electromagnetism holds your atoms together, and the nuclear forces hold the hearts of those atoms intact. You are a living testament to their unending, elegant, and collaborative work. A temporary masterpiece, sculpted by the unseen hands of the universe itself. This silent, perfect symphony of forces, this constant and collaborative work of the universe's architects, creates the beautiful and complex world we know. But it also gives rise to something else, something so fundamental that it is woven into the very fabric of our consciousness. A direction. We experience our lives as an unfolding story, a journey that moves inexorably from the past, through the present, and into the future. You can remember what you had for breakfast yesterday, but you cannot remember what you will have for lunch tomorrow. A glass can fall from a table and shatter into 1,000 pieces, but we never see 1,000 pieces leap from the floor to assemble themselves into a perfect glass. A drop of ink in a glass of water will slowly and beautifully cloud and disperse until the entire glass is a uniform, pale color, but we never witness a pale glass of water spontaneously gathering all its ink back into a single, perfect droplet. This one-way street of time, this constant and irreversible flow from order to disorder, is what we call the arrow of time. It is the universe's most profound and consistent habit, a silent current that carries everything along with it. This universal tendency has a name in science. It is the second law of thermodynamics, and the quantity it measures is called entropy. The word entropy can often sound cold and clinical, associated with decay and randomness and the eventual end of all things. But we can think of it in a much gentler, more intuitive way. Entropy is simply a measure of probability. The universe, like all things, tends to move from less probable states to more probable states. It is simply far more probable for the thousands of molecules in a drop of ink to be spread out among the trillions of water molecules than it is for them to be huddled together in one tiny corner of the glass. It is far more probable for the energy of a hot cup of tea to be shared with the cool air of the room than for it to remain neatly confined within the cup. The shattered glass has countless more ways to arrange its broken pieces on the floor than the single, highly specific arrangement that makes it a whole glass. And so, The forward march of time is simply the universe relaxing into more and more probable configurations. It is not an active, destructive force, but a gentle, passive letting go, a slow and steady settling into a state of greater equilibrium. It is the universe, quite simply, exploring all of its possibilities. The great and beautiful mystery, however, is that for this process to happen, for the universe to have a direction at all, it must have started in a state of the most profound and unimaginable improbability. For the arrow of time to have been fired, it had to be drawn back first into a state of exquisite and perfect order. All the evidence suggests that our universe began in a state of incredibly low entropy. Imagine the entire cosmos, all the matter and energy that would one day become 100 billion galaxies, wound up as tightly and as perfectly as a flawless crystal or a perfectly wound clock. This initial state was the ultimate expression of order, a condition of such profound simplicity and elegance that we can barely conceive of it. And the entire history of the cosmos, for the last 13.8 billion years, has been the story of that clock slowly unwinding, of that crystal slowly dissolving into the water of time, of that single, perfect ink drop of existence slowly and magnificently blooming outwards. The arrow of time that we experience every moment of our lives is a direct inheritance of that pristine, primordial state. We live in the long, lingering echo of that first, highly ordered moment. And this journey from order towards disorder is not just a story of decay. Paradoxically, it is the very thing that allows for the creation of beauty and complexity. The universe is not a closed, isolated system. As it expands and cools, the force of gravity is able to pull matter together into ordered pockets, into stars and galaxies. A star is a beautiful, highly ordered structure, but it can only exist by radiating an immense amount of disordered heat and light out into the void, increasing the total entropy of the universe far more than its own. Local ordering decreases it. Life, too, is a testament to this principle. You are a structure of breathtaking complexity and order, a living island of low entropy. But you maintain this order by taking in ordered energy from the world around you in the form of food and sunlight, and releasing disordered energy in the form of heat back into the environment. All the beauty and complexity we see is a temporary, local reversal of this cosmic tide, paid for by a greater increase in entropy elsewhere. And so the universe unfolds like a great cosmic flower, from a simple and highly ordered bud into the intricate, sprawling, and magnificent form it has today, a form that is, on the whole, less ordered, but so much richer, and which contains within it the possibility of you. And this slow, cosmic unfolding, this journey from a pristine and ordered beginning, is not just a process happening within the confines of space. It is a process that involves the very stretching and growing of space itself. For millennia, we looked up at the stars and saw them as fixed points in a static, eternal, and unchanging heavens. But in the early 20th century, a quiet revolution in our understanding began, led by the patient work of astronomers like Edwin Hubble. From a lonely mountaintop observatory in California, he used a new, powerful telescope to look deeper into the cosmos than anyone had before, at the faint, fuzzy patches of light that were then known as spiral nebulae. He discovered that these were not clouds of gas within our own Milky Way, but were in fact entire galaxies, island universes, just like our own, lying at immense distances from us. But he found something else, something that would forever change our perception of reality. When he measured the light coming from these distant galaxies, he found that almost all of them were moving away from us. And the further away a galaxy was, the faster it seemed to be receding. The entire universe was in a state of grand and uniform motion. The evidence for this motion was written in the light itself. When an object that is emitting waves, like sound or light, moves away from you, the waves are stretched out. You have experienced this with sound, in the phenomenon known as the Doppler effect. The siren of an ambulance sounds high-pitched as it approaches you, as the sound waves are compressed, and it drops to a lower pitch as it moves away. As the sound waves are stretched, light behaves in a similar way. If a distant galaxy is moving away from us, the waves of light it emits are stretched to longer wavelengths. In the visible spectrum of light, the longest wavelengths correspond to the color red. So, the light from these receding galaxies is shifted towards the red end of the spectrum, a phenomenon known as cosmological redshift. Hubble saw that the light from nearly every distant galaxy was redshifted, and the more distant the galaxy, the more its light was stretched, the greater the redshift. It was an unmistakable signature, a cosmic siren singing a lower and lower note the further it was from us. The universe was not static, it was expanding. This discovery conjures an image of a great explosion, of all the galaxies flying apart from a single central point out into a pre-existing, empty void. But the truth that Einstein's theory of general relativity revealed is even more profound and much gentler. The galaxies are not flying through space. The fabric of space itself is expanding, and the galaxies are being carried along for the ride. The most helpful and peaceful way to visualize this is to imagine a loaf of raisin bread dough rising slowly and gently in an oven. The raisins represent the galaxies, and the dough represents the fabric of space. As the dough bakes, it expands in all directions, and as it does so, it carries the raisins along with it. From the perspective of any single raisin, all the other raisins would appear to be moving away from it. A nearby raisin would move away slowly, while a raisin on the far side of the loaf would be carried away much faster, simply because there is more expanding dough between them. This is exactly what Hubble observed. The expansion isn't happening from a central point, it's happening everywhere, all at once. This means that our place in the universe is not special. There is no center of the cosmos from which everything is expanding. An observer in any galaxy, anywhere in the universe, would look out and see the exact same thing. All other distant galaxies receding from them in all directions. It is a truly universal phenomenon, a shared cosmic experience. This realization is a profound shift in perspective. The universe is not a static container, but a dynamic, living entity whose very fabric is growing. And as you lie here, this expansion is still happening, silently and ceaselessly. The space between our Milky Way and the most distant galaxies is stretching, growing larger with every passing moment. It is a slow, cosmic breath, an exhalation that has been going on for billions of years. And this breath, this constant, gentle expansion, provides us with the most powerful clue about our origins. For if the universe is expanding today, it means that yesterday it must have been smaller, and the day before that, smaller still. If we were to take this cosmic movie and play it in reverse, we would see all the galaxies, all the stars, all of space itself, rushing back together towards a single, ancient moment in the distant past when everything was in one place, in a state of unimaginable heat and density. The expanding universe is a signpost, pointing us directly backward in time, inviting us on a journey to its own beginning. And as we follow this thread of cosmic expansion backward in our minds, journeying to a time when all of existence was smaller, hotter, and denser, we might wonder if there is any tangible remnant of that fiery beginning left for us to find today. If the universe truly did begin in such a state of incredible heat, a kind of cosmic fireball, then the light from that fire, the intense radiation from that primordial furnace, should not have simply vanished. Scientists reasoned that as the universe expanded and cooled, this light would have cooled along with it. Its energetic, short wavelengths stretched over billions of years into much longer, lower energy wavelengths. They predicted that a faint, uniform afterglow of this creation event should still be detectable today, a whisper of radiation filling all of space, coming from every direction at once. It was a remarkable, bold prediction. The idea that the echo of the universe's first cry might still be faintly ringing through the cosmic halls, waiting for someone with a sensitive enough ear to hear it. For decades, it remained just a theory, a beautiful piece of mathematics on a page, until a moment of serendipitous discovery in the year 1965. Two American radio astronomers, Arno Penzias and Robert Wilson, were working with a large, horn-shaped antenna in New Jersey, trying to make sensitive measurements of the faint radio signals coming from our Milky Way galaxy. But they were troubled by a persistent, faint, and uniform noise in their signal, a gentle hiss, like the static you might hear between radio stations. It was a sound that they simply could not eliminate. They thought it must be an error in their equipment, a flaw in their meticulous design. They rechecked their calculations, recalibrated their instruments, and rebuilt their receivers. They even climbed into the Great Horn and cleaned out what they delicately called a white dielectric material, the droppings of pigeons that had been nesting inside. But no matter what they did, the hiss remained. It was constant, day and night, through every season of the year. It did not seem to come from the sun, or the center of our galaxy, or any other celestial object. It was coming, quite simply, from everywhere at once, with the same intensity in every direction they pointed their antenna. They had stumbled, quite accidentally, upon the oldest echo in the universe. This gentle, persistent hiss was the afterglow of the Big Bang. This signal, now called the cosmic microwave background, or CMB, is the most ancient light in the universe. The light that was first emitted was as hot and bright as the surface of a star, but over the course of 13.8 billion years of cosmic expansion, its wavelengths have been stretched by a factor of more than 1,000, from visible light into the microwave portion of the electromagnetic spectrum, invisible to our eyes but detectable by radio telescopes. This ancient light has a temperature, and it is incredibly cold, measuring just 2.73 degrees above absolute zero, the coldest possible temperature. This chill is the lingering temperature of the universe itself, the faint, residual warmth of its own birth. The cosmic microwave background is not a wall of light at the edge of the universe. It is a radiant atmosphere that permeates all of space, including the very room you are in now. This ancient light is streaming through you at every moment, a silent, invisible, and gentle rain of photons that has been traveling, unimpeded, since the dawn of time. This radiation is more than just an echo. It is a photograph. It is the universe's own baby picture, a snapshot of what the entire cosmos looked like when it was just a youthful 380,000 years old. When we create maps of the CMB, we see a pattern of incredibly tiny temperature fluctuations, minute differences in temperature from one spot in the sky to another, amounting to just 1 part in 100,000. These are not imperfections. They are the most important features in the entire image. Those slightly hotter, slightly denser spots represent the primordial seeds, the tiny gravitational lumps in the otherwise smooth fabric of the early universe. Over hundreds of millions of years, gravity would work on these tiny seeds, pulling more and more matter towards them, amplifying them, until they grew into the first stars, the first galaxies, and the great cosmic web of clusters and superclusters we see today. Everything you see in the night sky, every star, every galaxy, and indeed, you yourself, can trace your lineage back to one of those tiny, random fluctuations in that ancient, luminous fog. And so, in that faint, cold cosmic hiss, we see the blueprint of everything that was to come, the gentle, quiet promise of a universe filled with structure and beauty and life. This ancient, gentle light, this whisper of microwave radiation that fills all of space, is a beautiful and serene postcard from a distant past, but the universe it depicts was born from an era that was anything but serene. As we journey further back in time, beyond the moment that this first light was released, we plunge into a world of unimaginable energy, a luminous, chaotic fog. In the first few seconds after its beginning, the universe was so hot and so dense that the familiar structures of matter could not exist. It was not a cosmos of atoms, with electrons orbiting a stable nucleus. Instead, it was a seething, primordial soup, a plasma of fundamental particles packed into a volume smaller than a grain of sand. Protons, neutrons, and electrons, the building blocks of all future matter, ricocheted off one another at nearly the speed of light, while particles of light, photons, were so energetic and numerous that they were like a thick, glowing fluid, trapping the matter particles and preventing them from settling down. The universe was completely opaque, a wall of pure light, a place where the distinction between matter and energy was blurred in a brilliant, fiery haze. In this state, no structure was possible, no atoms, no molecules, no stars. only the raw, untamed potential of everything that would ever be. But the universe was expanding and cooling at a ferocious rate, and as the first second of its existence ticked by, the temperature dropped just enough for a moment of cosmic alchemy to occur. This period, lasting until the universe was about 3 minutes old, is known as the era of Big Bang nucleosynthesis. It was a fleeting, critical window of opportunity when the conditions were just right for the protons and neutrons, now moving a little more slowly, to begin sticking together, to fuse and form the first atomic nuclei. It was a frantic, beautiful dance of creation, governed by the delicate interplay of the fundamental forces. A proton and a neutron could collide and stick, bound by the strong nuclear force, to form a nucleus of deuterium, a stable, heavier form of hydrogen. Then, these deuterium nuclei could collide with each other, or with other protons and neutrons, to build up into even heavier nuclei. The entire universe, in these first few minutes, became a fusion reactor, forging the elemental building blocks that would define its chemical composition for all of future history. The results of this brief, universe-wide flurry of creation were profound and surprisingly simple. Most of the protons, the nuclei of hydrogen, never found a partner and remained as they were. This is why hydrogen is still, by far, the most abundant element in the cosmos. But a significant fraction of the protons and neutrons did successfully fuse, primarily into nuclei of helium-4, which consists of 2 protons and 2 neutrons. And a tiny, trace amount of lithium was also created. And then, after about 3 minutes, the show was over. The universe had expanded and cooled so much that the particles were now too far apart and moving too slowly for fusion to continue. The elemental composition of the cosmos was essentially fixed. About 75% of the universe's ordinary matter, by mass, was now hydrogen, and about 25% was helium, with everything else being a tiny fraction of a percent. This prediction that the early universe should have cooked up this specific ratio of hydrogen to helium is one of the most powerful pieces of evidence for the entire Big Bang model. Because when we look at the oldest, most pristine stars and gas clouds in the universe, this is precisely the ratio of elements that we find. You might wonder why this cosmic furnace didn't create all the other elements we know, the carbon, the oxygen, the iron that are so essential for life. The reason lies in the sheer speed of the cooling and expansion. The process was bottlenecked at the very first step, the formation of deuterium, and there are no stable nuclei with 5 or 8 particles, so building up to carbon, which has 12, was incredibly difficult in this rapidly thinning soup. Nature had to take these big, difficult leaps, and there simply was not enough time. The universe had created its 2 most basic elements, its foundational pillars, and then it had to patiently wait. The forging of the heavier elements, the elements of planets and of life, would have to be outsourced to a new kind of factory, one that would not come into existence for hundreds of millions of years. The fiery hearts of the first stars. And so, at the tender age of 3 minutes, the cosmic script was partially written. The universe was now a vast, expanding, and still opaque cloud of hydrogen and helium nuclei, bathed in a sea of brilliant light, waiting patiently for the long, slow process of cooling that would eventually allow the electrons to be captured, the atoms to form, and the first light to finally break free. For hundreds of thousands of years after its first few minutes of creation, the vast expanding cloud of hydrogen and helium nuclei remained a prisoner of its own brilliant light, a universe that was everywhere bright, yet a universe in which one could not see. It is a strange and paradoxical state to imagine. The cosmos was filled with an incredible density of photons, particles of light, so much so that it was a single, unified, glowing entity. But this very brilliance was what made it opaque. The universe was a luminous fog, an impenetrable haze of energy and matter bound together in a frantic dance. The temperature was still thousands of degrees, and the photons were so energetic that they behaved like tiny, violent projectiles. In this primordial plasma, the universe's free-roaming electrons were the primary obstacle to clarity. Whenever a proton, a hydrogen nucleus, would try to capture a passing electron to form a stable atom, an energetic photon would instantly slam into it, knocking the electron free once again. This process repeated itself trillions upon trillions of times per second, all across the cosmos. Light could not travel more than a few moments before being scattered by an electron. Its path instantly changed, its journey cut short. It was like trying to see through the densest fog imaginable, where the light from a flashlight is instantly scattered back at you, illuminating only the haze itself, but nothing beyond it. But all the while, the universe continued its patient, steady expansion. And as space stretched, the light within it stretched as well, its energy slowly diminishing, its temperature gradually dropping. For 380,000 years this cooling continued, a long, slow exhalation that gradually tamed the fiery chaos of the universe's youth. The cosmos expanded to about 1/1000th of its current size, and the temperature of this primordial plasma finally fell to a critical threshold, a tipping point in cosmic history. The temperature dropped to roughly 3000 degrees Kelvin, similar to the surface of a cool red star. At this temperature, the average energy of the photons finally fell below the amount required to knock an electron away from a proton. The frantic, energetic assault of the light particles on the fledgling atoms finally subsided. The universe had become, at last, calm enough for matter to find a lasting peace. And so began the era of recombination, a gentle and beautiful moment of universal settling. Across the entire expanse of the cosmos, almost in unison, the free electrons were finally captured by the patient hydrogen and helium nuclei. The frantic, chaotic dance of repulsion and collision gave way to a quiet, stable partnership. Electrically neutral atoms were formed for the very first time. Protons and electrons paired off, their opposing charges cancelling each other out, creating a universe that was no longer a seething plasma, but a vast and peaceful cloud of neutral gas. This was not a chemical reaction in the way we think of it, but a fundamental change in the state of the entire universe. A phase transition like steam condensing into water, but on a cosmic scale. It was a moment of profound clarification, the universe letting go of the chaos of its infancy and settling into the form that would define its future. The formation of these first atoms was the universe taking a deep, calming breath, the end of its fiery, energetic youth, and the beginning of its long and patient adulthood. And in the moment that these atoms formed, in the instant the free electrons were swept from the cosmic stage and bound into their quiet orbits, the universe became transparent. The fog that had shrouded all of existence for 380,000 years vanished, clearing instantly and everywhere. The photons, which for millennia had been trapped in an endless pinball game, ricocheting from one electron to the next, suddenly found themselves in an empty and open space. Their primary obstacle was gone. For the very first time, light was free to travel in long, unimpeded, straight lines across the cosmos. This moment is known as photon decoupling, the great unveiling. And so, from every point in the universe, light from this last moment of interaction, this surface of last scattering, was released and began a journey that would continue for billions of years. This great, initial flash of liberated light, cooled and stretched by the subsequent expansion of space, is what we see today when we look at the cosmic microwave background. It is the oldest and most distant light our telescopes can possibly see. A perfect, fading photograph of the very moment the universe decided to become clear, the moment it opened its eyes for the first time. And as that first great flash of light, the afterglow of creation, began its long and silent journey across the cosmos, it left behind a universe that was, for the first time, transparent, but also a universe that had fallen into a profound and lasting darkness. The brilliant, luminous fog was gone, but in its place, there was nothing yet to shine. There were no stars to pierce the gloom, no galaxies to swirl in the velvet emptiness. There was only a vast, expanding, and perfectly dark space, filled with enormous, cold, and thinning clouds of neutral hydrogen and helium gas. This immense and silent period, which began after the light of recombination faded, is known as the Cosmic Dark Ages. For hundreds of millions of years, the universe was a place of profound and uninterrupted quiet. The only thing happening on a grand scale was the slow, steady expansion of space, and the even slower, more patient work of gravity. It is a period of cosmic history that is almost impossible to truly imagine. An era of utter blackness on a scale that dwarfs any darkness we have ever known, a silent and starless sky that stretched on for an almost eternal-seeming length of time. But even in this profound and patient darkness, the seeds of the future were slowly beginning to germinate. Gravity, the universe's most patient and persistent sculptor, was quietly at work. The baby picture of the universe, captured in the cosmic microwave background, had shown us that the primordial gas was not perfectly uniform. There were tiny, random fluctuations, regions that were infinitesimally denser than the areas around them. And in the silent theatre of the Dark Ages, these tiny imperfections became the focal points for creation. Gravity, acting over millions of years, began to gently tug on the surrounding gas, pulling it ever so slowly towards these slightly denser regions. It was a process of almost imperceptible slowness, a gathering of cosmic whispers in the dark. As more and more gas was drawn in, the density of these regions grew, and their gravitational pull became stronger, pulling in yet more gas in a slow, steady feedback loop of creation. For 200 million years or more, these clouds, the first protogalaxies, grew larger and more compact, their cores becoming ever denser and ever hotter under the strain of their own immense weight. Then, finally, in the hearts of the densest of these dark clouds, the pressure and temperature reached a critical point, the 10 million degrees necessary for nuclear fusion to begin. And the long, cosmic night was finally broken. The first stars ignited. These were not stars, like our sun. They were a different breed, a generation of stars that astronomers call population. 3 stars. Because they were formed from the pristine, unenriched hydrogen and helium gas of the early universe, they were giants, titans of a scale we do not see today, hundreds of times more massive than our own sun. And because of their incredible mass, they burned with an almost unimaginable ferocity. They were colossal, blue-white furnaces, pouring out torrential amounts of high-energy ultraviolet radiation into the surrounding darkness. They lived fast and they died young, burning through their entire supply of nuclear fuel in just a few million years, a mere blink of an eye in cosmic terms. They were the lonely, brilliant lighthouses that brought the cosmic dark ages to an end. This new dawn is called the era of reionization. The intense, energetic light from these first giant stars streamed out into the cold, neutral gas that still filled the universe, and it was powerful enough to strip the electrons away from their atoms once again, to ionize the gas. It was as if a great fog was being burned away, not by clearing it, but by making it glow from within. One by one, then in clusters, then in great waves, these first stars, and the first primitive galaxies they formed, began to light up the cosmos. Their overlapping bubbles of reionized gas, eventually merging until the entire universe was once again a plasma. But this time, a thin, hot, and transparent plasma, punctuated by the brilliant lights of its first stellar children. The long silence was over. And when these first, giant stars reached the end of their short, brilliant lives, they exploded as the first supernovae, seeding the cosmos for the very first time with the heavier elements that would be required to build the rocky planets, the complex chemistry, and eventually the life that was to come. The universe had begun its great cycle of creation, and its song of light and matter had begun at last. And so, with the universe now filled with the light of a billion stars, with galaxies forming and beginning their slow, majestic dance across the cosmic stage, we might have been forgiven for thinking that we were finally seeing the complete picture, that the story of the cosmos was written entirely in this visible, luminous matter that we had come to understand. The stardust, the great clouds of gas, the brilliant stellar furnaces, and the planets they warmed all seemed to be part of a coherent and complete story. Yet, as our observations grew more precise, a quiet and persistent mystery began to emerge from the darkness between the stars. The universe, it seemed, was hiding a profound secret from us. The first whispers of this secret came from watching the way that galaxies spin. In the 1970s, the astronomer Vera Rubin and her colleagues spent countless hours patiently observing spiral galaxies, much like our own Milky Way, measuring the speeds of the stars orbiting within them. Logic would suggest that the stars farther out from the dense, bright galactic center should be moving more slowly, just as the outer planets of our solar system orbit the sun more slowly than the inner ones. But this is not what she found. Instead, she discovered that the stars in the outer arms of these galaxies were moving just as fast as the stars closer in. They were orbiting at speeds so tremendous that the gravitational pull of all the visible matter in the galaxy, all the stars and gas we could see, should not have been nearly strong enough to hold on to them. These outlying stars should have been flung off into the lonely darkness of intergalactic space. And yet, there they were, held in a stable, rapid orbit, as if in the grip of some vast, unseen, and powerful gravitational force. This strange anomaly was not an isolated case. It was seen in galaxy after galaxy. The cosmic symphony had a note that was inexplicably off-key. A second, independent line of evidence soon emerged, one that came from observing the way light travels across the universe. Albert Einstein's theory of general relativity tells us that mass warps the fabric of spacetime, and that light, as it travels through this warped space, will follow a curved path. This means that any large concentration of mass, like a galaxy or a cluster of galaxies, can act as a giant cosmic lens, bending and magnifying the light from even more distant objects that lie behind it. We see this effect, known as gravitational lensing, all the time. We see the light from a single distant galaxy smeared into beautiful, ghostly arcs and rings as it passes through a massive galaxy cluster on its way to us. It is a stunning confirmation of Einstein's theory. But when we calculate the amount of mass needed to create the lensing effect we observe, we find, once again, that the visible matter is not nearly enough. The amount of gravitational bending is 5 or 6 times greater than what all the stars and gas can account for. There had to be a colossal amount of invisible mass hiding in plain sight, its presence revealed only by its powerful gravitational influence on the light that passed by. This mysterious, unseen substance was given a simple and fitting name: dark matter. The name can be a little misleading, for this matter is not dark in the way that a lump of coal is dark. A lump of coal absorbs and blocks light, and we can detect it by the shadow it casts. Dark matter, however, is completely transparent. It does not emit, absorb, reflect, or scatter light in any way. It is utterly invisible, a true ghost in the cosmic machine. Its only known interaction with our familiar world is through the gentle, persistent, and powerful pull of its own gravity. We have come to understand that this dark matter is not some minor, exotic addition to the cosmos. It is the dominant form of matter in the universe. For every 1 kilogram of the ordinary matter that makes up you, the Earth, and the stars, there are more than 5 kilograms of this mysterious dark matter. It is the silent majority of the cosmic population, an invisible ocean in which the shining islands of the galaxies are suspended. And it is not just an observer. Dark matter, we now believe, was the primary architect of the universe we see today. In the early cosmos, before the first stars ignited, it was this dark matter that collapsed first, forming vast, invisible, spherical structures called halos. These halos then acted as the gravitational scaffolding for everything that was to come. Their immense gravity created deep wells in spacetime, which then attracted the ordinary matter, the hydrogen and helium gas, pulling it into the centers of these halos where it could cool, condense, and eventually form the galaxies we see. The luminous, spiraling galaxies are therefore just the glowing tips of a much larger and much more massive, invisible iceberg. We are living inside one of these great, invisible structures. And so, as you rest here, you are being held to the Earth by its gravity, which is orbiting the Sun, which is being held in the Milky Way by the collective gravity of all the stars, which is itself being held together by a vast, silent, and mysterious sphere of matter that we cannot see, cannot touch, and cannot yet comprehend. We are guests in a house whose true shape and substance remain a profound and beautiful mystery, while this gentle, invisible ghost of dark matter was patiently pulling the universe together, building the grand structures that would house the future stars and planets. Another, even more mysterious and subtle character was beginning to make its presence felt on the cosmic stage. This new influence was not a force of attraction, but a quiet, persistent, and ever-growing push. For most of the 20th century, the greatest question in cosmology was about the ultimate fate of the universe. It was clear that the universe was expanding, but the gravity of all the matter within it, both visible and dark, was acting as a constant brake, pulling everything back together. The great debate was whether the expansion would eventually slow down, halt, and reverse, leading to a big crunch, or whether it had enough momentum to overcome gravity and expand forever, but at an ever-slowing rate. In the late 1990s, two independent teams of astronomers set out to settle the question once and for all. They planned to measure the rate of this cosmic slowdown by looking at extremely distant Type Ia supernovae, a special kind of exploding star whose intrinsic brightness is so consistent that it can be used as a standard candle to measure cosmic distances with incredible precision. They were looking deep into the past, measuring how the expansion rate had changed over billions of years. And what they found was not just surprising, it was world-shattering. The expansion of the universe was not slowing down, it was speeding up. This discovery was so profound that it felt like throwing a ball into the air and watching it accelerate away into the sky. It went against everything we thought we knew. Some unknown influence was at work, overwhelming the collective gravitational pull of all the matter in the cosmos, and actively pushing space itself apart at an ever-increasing rate. This mysterious cause, this cosmic accelerant, was given a name that echoes the great mystery of our time: dark energy. Unlike dark matter, which clumps together gravitationally to form structures, dark energy appears to be a smooth, uniform, and persistent property of space itself. It does not seem to dilute as the universe expands. Instead, as more space is created, more of this energy seems to appear along with it, creating an even stronger push. It is a gentle but inexorable pressure inherent in the fabric of the vacuum, a silent, outward-facing sigh that is woven into the very nature of reality. It is a force that grows stronger as the universe grows larger. In a strange and beautiful twist of scientific history, this bizarre idea was not entirely new. Back in 1917, when Albert Einstein first applied his new theory of general relativity to the entire universe, his equations told him that the cosmos should be either expanding or contracting. But the prevailing view at the time was that the universe was static and eternal. To make his equations match this idea, he added an extra term, a kind of mathematical fudge factor that he called the cosmological constant. It acted as a sort of cosmic repulsion, a form of anti-gravity that would perfectly balance the inward pull of matter to create a stable, unchanging universe. When Edwin Hubble discovered a few years later that the universe was in fact expanding, Einstein famously discarded the cosmological constant, calling it his biggest blunder. And yet, decades later, the discovery of the accelerating expansion brought his old idea roaring back. The simplest and still best explanation for dark energy is that something very much like Einstein's cosmological constant is real, that the vacuum of space itself possesses an intrinsic energy that drives the cosmos apart. His greatest blunder may, in fact, have been one of his most prescient insights into the true nature of reality. And so, we are left with a new and humbling inventory of our universe. If we were to take all the stuff of the cosmos, all the matter, and all the energy, and put it into a single pie chart, the slice for the ordinary matter that makes up everything we have ever seen or touched or dreamed of, every star, every planet, every human being, would amount to just about 5%. The slice for the mysterious dark matter, the invisible scaffolding that holds the galaxies together, would be about 27%. And the rest, a staggering 68% of the total energy density of the universe, is made of this enigmatic dark energy. We are living in a cosmos whose behavior and ultimate fate are overwhelmingly dominated by two ingredients that we have only discovered in the last few decades, and whose fundamental nature remains a complete mystery. As you float here in the quiet darkness, this silent, gentle push of dark energy is continuing its work, widening the space between the great clusters of galaxies. It is a slow, gradual, and peaceful process, a quiet unfurling that is carrying us towards a vast, and perhaps lonely, future. A future where the silence between the galaxies grows ever wider, and the night sky slowly, over trillions of years, fades to a beautiful and profound emptiness. And as we contemplate this vast, unfolding future, this quiet expansion into a lonely infinity, driven by a mysterious dark energy, our journey now turns back once more, seeking its final destination at the very beginning of time. We drift backwards now, past the era of the quiet expansion, past the mystery of the invisible dark matter, past the first lonely stars piercing the cosmic dark ages, past the great unveiling when the universe first became transparent, and past the fiery alchemy of the first 3 minutes. We are journeying back to a moment so early, so impossibly close to the beginning, that our most fundamental concepts of time, of space, and of physical law begin to dissolve into a realm of pure and beautiful speculation. We are approaching the very edge of our scientific understanding, a boundary known as the Planck era. This era is defined by the Planck time, a unit of time so infinitesimally small it defies all human intuition. It is 10 to the power of negative 43 seconds, a decimal point followed by 42 zeros, and then a 1. It is a duration so brief that, compared to it, a single second is as long as the entire age of the universe multiplied by 1,000,000,000,000. It is, for our current theories of physics, the first possible tick of the cosmic clock. Before this moment, in the searing, unimaginable heat and density of the universe's birth, we believe that the 4 fundamental forces of nature, which govern our cosmos in such a beautiful and distinct harmony today, were themselves unified. The patient pull of gravity, the binding force of electromagnetism, the unbreakable strong nuclear force, and the subtle weak nuclear force are all thought to be different aspects of a single, elegant, and underlying superforce. In this primordial state, the universe would have possessed a perfect and profound symmetry, a time before the distinct personalities of the forces had frozen out from the cooling cosmos, like steam condensing into water and then freezing into the intricate, separate patterns of a snowflake. This Planck era was a time of ultimate simplicity, a point of perfect unity from which all the complexity and diversity of the modern universe would eventually be born. It represents the ultimate, and as yet unsolved, quest of modern physics. To find the single equation, the single principle that would unite all the forces of nature and describe this first, unified moment of existence. But as we try to peer into this realm, our 2 greatest theories of physics, general relativity, which describes the universe of the very large, and quantum mechanics, which describes the universe of the very small, begin to give us conflicting and paradoxical answers. It is here, at the Planck scale, that the smooth, continuous fabric of spacetime, described by Einstein, is thought to break down into a chaotic, bubbling, and probabilistic state. This theoretical state is sometimes called the quantum foam. Imagine a realm where space and time are no longer a stable stage, but a turbulent ocean of pure potential. Tiny wormholes, temporary rips in the fabric of reality, and fleeting, microscopic universes could be constantly bubbling in and out of existence. In this quantum foam, the very notions of here and there, of before and after, would lose their familiar meaning. Time itself would not flow like a river, but would be a chaotic, uncertain, and granular landscape. It is a place beyond all of our sensory experience, a reality described only by the strange and beautiful mathematics of quantum probability. This is the absolute frontier of human knowledge, not because the universe is being deliberately mysterious, but because we simply lack the language to describe it. To understand this era would require a new theory, a theory of quantum gravity, one that could finally weave together the laws of the large and the small into a single, coherent tapestry. Scientists are searching for this theory, with ideas like string theory and loop quantum gravity. But for now, the Planck era remains a beautiful and profound mystery, a veil beyond which we cannot yet see. And so, rather than a place of definite answers, we can imagine it as a place of infinite questions. It is the ultimate seed from which our reality grew, a place of pure and untamed potential, a chaotic and vibrant silence from which the first, stable note of our expanding spacetime was about to be played, setting the stage for the grand and orderly cosmos we have come to know. From this turbulent, unimaginable foam of pure potential, a universe like ours, so vast, so smooth, and so uniform on the largest of scales, had to emerge. And the story of how it likely did so is not one of slow, steady growth, but of a single, breathtaking moment of expansion that occurred in the very first fraction of a second. The standard story of the Big Bang, as powerful as it is, left a few deep and nagging puzzles for cosmologists to ponder. The first of these is known as the horizon problem. When we look at the cosmic microwave background, that beautiful baby picture of the universe, we find that it is almost perfectly the same temperature in every direction we look, to a precision of 1 part in 100,000. But in the standard model of an expanding universe, two opposite points in that sky should never have had time to be in contact with each other. Light, the fastest messenger in the cosmos, would not have had enough time, in the first 380,000 years of history, to travel from one side to the other, to share its heat and even out its temperature. So how did these distant, disconnected regions all know to arrive at the exact same temperature? It was a cosmic coincidence of the highest and most improbable order. A second puzzle is known as the flatness problem. According to Einstein's theories, spacetime can have a curvature. It can be curved positively, like the surface of a sphere, or negatively, like the surface of a saddle, or it can be perfectly flat, like a sheet of paper, where the familiar rules of Euclidean geometry apply. All of our measurements today show that our universe is incredibly, remarkably close to being perfectly flat on the largest scales. But any tiny deviation from perfect flatness at the beginning of the universe would have been dramatically amplified by the subsequent 13.8 billion years of expansion. For the universe to be so close to flat today, it must have started out flat to a precision of 1 part in 10 to the power of 60, a number so absurdly close to perfection it seemed to defy any natural explanation. It felt as though the universe had been born with its dials tuned with an impossibly fine and delicate hand. These puzzles suggested a crucial piece of the story was still missing, a chapter that must have taken place in the universe's very first moments. The most elegant and widely accepted solution to these problems is a remarkable theory known as cosmic inflation. This theory proposes that in the first sliver of a second of its existence, from about 10 to the power of negative 36 to 10 to the power of negative 32 seconds, the universe underwent a period of violent, hyper-accelerated, exponential expansion. It was not a normal expansion, but a runaway process, driven by the energy of the vacuum itself. During this tiny fraction of a second, the universe is thought to have doubled in size at least 100 times, expanding by a factor greater than a 1 followed by 30 zeros. It was as if the cosmos took a single, deep, and impossibly powerful breath. A region of space far smaller than a single proton was stretched in this instant to become a volume far larger than our entire observable universe today. This single, cataclysmic event would have set the stage for the calmer, hot Big Bang that followed. This one, simple idea elegantly solves the great cosmic puzzles. It solves the horizon problem because the entire observable universe we see today, from one horizon to the other, originated from a tiny, subatomic patch of space before inflation began. This tiny region was small enough to have been in thermal contact, to have evened out its temperature perfectly. Inflation then stretched this smooth, uniform patch to its current immense size, preserving that uniformity on a cosmic scale. And it solves the flatness problem with a simple and beautiful analogy. Imagine a tiny, curved balloon. If you inflate that balloon to the size of the Earth, any small patch on its surface will appear, to an ant walking on it, to be perfectly flat. Inflation did the same thing to the universe. It expanded the cosmos by such an astronomical factor that any initial curvature it might have had was stretched out to the point of being imperceptible. The tiny, random quantum fluctuations present in that initial patch were also stretched, becoming the macroscopic seeds of slightly different density that would later grow into all the galaxies and clusters of galaxies. And so, in this single, violent breath, the universe was born, flat, uniform, and seeded with the origins of all future structure, ready for its long and beautiful story to unfold. And so we find ourselves contemplating this almost magical image, our entire vast and beautiful cosmos, born from a single, infinitesimal seed that was stretched in a breath of incomprehensible power. But this profound idea of inflation only pushes our final question one step further, back into the quiet mystery. From what did that tiny, primordial seed itself arise? As we try to trace the thread of cosmic history back beyond the moment of inflation, back to the very first instant of time, our best classical theory of gravity, Einstein's general relativity, points towards an inescapable conclusion. If you run the movie of the expanding universe backward, all of the matter and energy, all of the space-time fabric that makes up our reality, converges upon a single, solitary point. A point of zero volume, and therefore of infinite density and infinite temperature. This theoretical point is known as the gravitational singularity. It is, in our classical story of the cosmos, the ultimate origin, the single dimensionless seed from which the entire tree of existence grew, the first letter in the first word of the cosmic story. It is the beginning, not just of matter and energy, but of space and time itself. For many years, this was the accepted, if deeply strange, image of our universe's birth. But in the world of modern physics, the concept of a true, physical infinity is often seen not as an answer, but as a warning sign. An answer of infinity is like a red light on a dashboard, a signal that the theory you are using has been pushed beyond the realm where it is valid, and a new, deeper, and more complete theory is needed to understand what is truly happening. General relativity is a magnificent and powerful theory for describing gravity on the large scales of stars and galaxies, but it does not contain the strange and probabilistic rules of quantum mechanics which govern the world of the very small. And at the origin of the universe, the entire cosmos was smaller than a single atom, a realm where both gravity and quantum mechanics must have reigned supreme. And so, most physicists today do not believe that the universe ever actually existed as a point of infinite density. The singularity is not a description of a real, physical state, but rather a description of the limits of our own knowledge. It is the place where our current language of mathematics falls silent. We can think of the singularity, then, not as a physical location, but as a horizon to our understanding. It is a beautiful and profound boundary that marks the end of our theories of time and space as we know them. And this leads to an even deeper thought. If time itself was created in the Big Bang, then the very question of what came before the singularity may be a meaningless one. It would be like asking, what is north of the North Pole? The concept of before requires the existence of time in which to happen. The singularity may not be the first moment in a long, pre-existing timeline, but the very beginning of the timeline itself. It is the ultimate vanishing point, the source from which the river of time begins to flow. It is the question mark that hangs not at the end of a sentence, but at its very beginning, the silent, generative void from which the first sound of creation emerged. And as our minds gently approach this boundary of our knowing, it is calming to realize that new ideas are constantly being explored to see beyond this wall. Some theories propose that the singularity was not a beginning, but a moment of transition. The idea of a big bounce suggests that our universe may have emerged from the collapse of a previous, older universe, which crunched down to an incredibly dense state and then bounced, re-emerging as the expanding cosmos we know. Other models imagine a cyclical universe, a reality that has been expanding and contracting for eternity, with each new Big Bang being the rebirth of the cosmos from the ashes of the last. These ideas are still speculative, but they open our minds to the possibility that what we call the beginning was simply one chapter in a much older and perhaps eternal story. And so, we can let our minds rest here, at this point of infinite beginning, not in frustration at the limits of our knowledge, but in deep and peaceful awe of the ultimate mystery, the silent, single, and unknowable origin from which all of space-time, all of matter, and all of energy so beautifully bloomed. And as we gently pull our minds away from that silent, unknowable point of origin, we can turn our gaze instead to the magnificent creation that bloomed from it. And when we do, we find ourselves faced with a new and equally profound kind of mystery. We have journeyed through the story of how the universe came to be, through its fiery birth, its slow cooling, and the gradual emergence of the stars and galaxies. But now, as our journey begins to turn towards home, we can begin to contemplate the question of what kind of universe this process created. And what we find is something quite astonishing. The universe that surrounds us, the universe that has given rise to us, appears to be exquisitely and improbably fine-tuned for the existence of complex structures and for life itself. The fundamental constants of nature, the unchanging numbers that underpin all of physics, seem to have values that are set with an incredible and delicate precision, as if a great cosmic dial had been tuned to the exact, perfect frequency that would allow for our existence. Let us consider, for a moment, the quiet strength of the strong nuclear force, the force that binds protons and neutrons together in the heart of an atom. If this force had been just a few percent weaker than it is, protons and neutrons would never have been able to stick together in the early universe. No deuterium would have formed, and the only element in the cosmos would be hydrogen. Without heavier elements, there would be no rocky planets, no carbon, no oxygen, no water, and no life. Conversely, if the strong force had been just a few percent stronger, the fusion process in the early universe would have been far too efficient. All of the hydrogen would have been rapidly cooked into heavier elements, leaving no fuel for long-lived stable stars like our Sun. In either case, a universe with stars, planets, and chemistry would have been impossible. The value of this force lies in an exquisitely narrow, life-permitting window. Or consider the subtle, gentle push of dark energy, the cosmological constant. We now know that its value is incredibly small, but positive, causing the universe to accelerate its expansion at a leisurely pace. If this value had been much larger, its repulsive force would have been overwhelming from the very beginning. It would have ripped the universe apart before the pull of gravity ever had a chance to gather matter together. No galaxies, no stars, and no planets would have ever formed. If, on the other hand, the value had been negative, the universe would have long ago collapsed back in on itself in a big crunch, never allowing enough time for the slow, patient process of evolution to unfold. Our universe exists on a knife's edge of stability, a delicate and beautiful balance between flying apart and crushing back in on itself. Countless other examples exist, from the precise mass difference between a proton and a neutron to the relative strengths of gravity and electromagnetism. In case after case, the fundamental parameters of our cosmos seem to be perfectly set for life. This observation has led to a framework for thinking known as the anthropic principle. In its simplest form, the weak anthropic principle suggests that we should not be surprised to find ourselves in a universe that appears fine-tuned for our existence. It is, in a sense, a selection effect. If the universe had not been this way, we simply would not be here to observe it and to wonder about it. It is like a lottery winner marveling at their own incredible luck. It is indeed incredibly unlikely for any one person to win, but someone eventually does, and that person can then reflect on the improbable series of events that led to their good fortune. So, perhaps, we are simply the inhabitants of that one fortunate cosmos that happened to get all the settings just right. This perspective reframes the mystery from one of unbelievable design to one of unbelievable luck, a cosmic chance that has allowed for this grand and intricate tapestry of existence to be woven, a tapestry in which every thread, every physical constant, and every law seems to have been chosen with perfect care, creating a final, magnificent image of a universe that is capable of waking up and knowing itself. And so we are left with this gentle, resonant question that echoes in the quiet chambers of the mind. Is our universe a singular, fortunate accident, a one-of-a-kind masterpiece created by an improbable alignment of cosmic constants? Or could it be that this finely woven tapestry of our existence, so perfectly suited for the emergence of complexity and consciousness, is but one thread in an even grander, and perhaps infinite, cosmic fabric? This latter idea, once the sole domain of philosophy and fiction, has in recent decades found a tentative and beautiful home within theoretical physics. The concept of the multiverse arises not from a desire for a grander story, but as a natural and in some cases, almost unavoidable consequence of some of our most promising scientific theories. It offers a simple, if breathtakingly vast, solution to the mystery of our own fine-tuned existence. For if there are countless other universes, a near infinite ensemble of other cosmoses, each with its own randomly set physical laws and constants, then it is no longer a matter of surprise that at least one of them, by sheer chance, would happen to have the correct combination of settings for life to emerge. The existence of our universe becomes, in this grander picture, not an astonishing improbability, but a statistical inevitability. We are here, wondering about it, because we are, by definition, in one of the universes where we could be. One of the most compelling scientific paths to this conclusion comes from the theory of cosmic inflation, the same theory that so elegantly describes the first moments of our own universe's growth. The inflationary energy field that drove our universe's exponential expansion may not have decayed everywhere at once. The current thinking suggests that this process might be eternal. While inflation came to an end in our particular region of space, allowing our bubble to form and evolve into the cosmos we know, the inflationary process may be continuing, even now, in the vast ocean of spacetime beyond our observable horizon. This process, known as eternal inflation, would be constantly spawning new, isolated bubble universes, each one budding off from the ever-expanding whole. Each time a new bubble forms, its own Big Bang occurs, potentially with its own unique set of physical laws and fundamental constants that have frozen out from the primordial state in a different way. We can imagine this grand reality as a vast, eternal ocean of shimmering, energetic foam, constantly churning and expanding. Our entire observable universe, with its hundreds of billions of galaxies, is but a single, tiny bubble that has nucleated within this ocean, a calm and stable pocket where the energy has settled down, allowing for the formation of matter and structure. And all around us, in this vaster reality that we can never hope to see or interact with, other bubbles may be forming at every moment. These other universes would be completely disconnected from our own, true islands in an infinite sea, each one a self-contained cosmos with its own story unfolding within it. Some might be much like our own. Others might be radically different, with more or fewer dimensions of space, with different fundamental particles, with forces of nature that would be completely alien to us. Most, perhaps almost all of them, would be sterile, empty, and devoid of the complexity needed for life, collapsing in an instant or flying apart too quickly for any structure to form. But in an infinite lottery, even the most improbable set of winning numbers will eventually be drawn. Another path to this same grand vista comes from what is currently our best candidate for a final theory of everything, string theory. In its attempt to unite gravity with quantum mechanics, this theory suggests that the fundamental constants of nature are not arbitrary, but are determined by the way extra, hidden dimensions of space are curled up and shaped. The theory predicts a vast number of ways for these dimensions to be configured, perhaps as many as 10 to the power of 500 different possibilities, each one leading to a universe with its own unique set of physical laws. This collection of possible universes is often called the string theory landscape. And if eternal inflation is also true, it might provide the mechanism for creating all of these possibilities, with each new bubble universe realizing one of the potential designs from the landscape. And so our perspective gently expands. The feeling of home, which once began with our planet, then grew to our solar system, our galaxy, and finally our entire observable universe, now opens up to an even grander possibility, that our universe is our home island in a vast and silent cosmic archipelago, a single, fortunate world in an eternal and perhaps infinite ocean of creation. As we float in this imagined ocean of countless universes, this grand and silent cosmic archipelago, our sense of the physical world expands to an almost unimaginable scale. The very ground of our reality, the stage upon which our existence plays out, has become immeasurably vast and deep. And yet, there is another journey we can take, a final turn in our contemplative path, one that leads not outwards into an even vaster space, but inwards, into the very meaning of what it is for a universe to be real at all. For millennia, we have thought of the world as being made of stuff, of matter and energy, of particles and fields. But a new and profound perspective is emerging from the depths of physics, one that suggests that the most fundamental ingredient of reality may not be matter or energy, but something far more ethereal: information. We can begin to feel our way into this idea by thinking about something we have already met: entropy. We first understood it as a measure of disorder, the universe's tendency to relax into more probable states. But it can also be understood as a measure of missing information. A perfectly ordered room, a bedroom where every object is in its designated place, is a state of low entropy, because you have a great deal of information about it. You know exactly where everything is. A messy, disordered room is a state of high entropy, not just because it is chaotic, but because you have less information about the precise location of any given object. The unfolding of the universe, then, can be seen as a story in which information about its initial, perfect state is slowly being lost, or rather, spread out and diluted. This deep connection between the physical world and the abstract world of information was beautifully captured by the renowned physicist John Archibald Wheeler in a simple, poetic phrase: "It from bit." This is the radical and beautiful hypothesis that every it, every physical thing, every particle, every quantum field, even the fabric of space-time itself, ultimately derives its existence and its meaning from bits, from the fundamental units of information. At the very bottom level of reality, the universe may not be asking questions of substance, but questions of choice. Simple, binary, yes or no questions, the answers to which build up, layer upon layer, to create the rich and complex world we perceive. In this view, the universe is not so much a great machine, but a great thought, a grand computation that is constantly processing information to generate the illusion of substance and motion and time. The physical world, in all its grandeur, emerges from an underlying, immaterial code. Perhaps the most startling and mind-bending scientific idea to emerge from this line of thinking is known as the holographic principle. It arises from the study of black holes, but its implications are for the entire cosmos. It suggests, in a mathematically rigorous way, that all of the information contained within a given volume of space can be completely and perfectly described by a theory that lives on the two-dimensional surface that bounds that volume. This is much like a hologram, where a three-dimensional image is fully encoded on a flat, two-dimensional piece of film. Could it be that our reality, with its 3 dimensions of space and one of time that we experience so vividly, is itself a kind of holographic projection? Could it be that all the richness of our world, the feeling of depth, the existence of solid objects, is an emergent property of a simpler, two-dimensional reality written on some distant cosmic boundary, like the surface of our cosmic horizon? This idea is still at the forefront of theoretical physics, but it offers a profoundly new and peaceful way to imagine our place in the cosmos. If we allow our minds to gently entertain this possibility, then the universe becomes something akin to a story, a dream, or a piece of music. The fundamental laws of physics are the grammar of that story, the algorithm of that dream, or the harmonic rules of that music. The unfolding of the cosmos from the Big Bang onwards is the narrative itself, the playing out of that code through time. And we, as conscious beings, are not just passive observers of this story. Our own minds, our own thoughts and feelings, are themselves intricate patterns of information. We are, perhaps, the universe's way of reading its own story, of the code becoming aware of itself. In this gentle, final turn of thought, the cosmos becomes not a cold, empty place of disconnected objects, but an intimate, interconnected, and meaningful whole. And you, resting here, are not a stranger in a strange land, but a living expression of the cosmic code, a note in the universal song, a dream that the universe is dreaming of itself. And if we are indeed a dream that the universe is dreaming, a story that it is telling to itself, then what a truly remarkable and beautiful story it has been. It is a story that has been unfolding for 13.8 billion years, leading, in an unbroken and causal chain of events, from the silent, infinite potential of the beginning to this very moment, to you, resting here, now. Let your mind gently drift back one last time along this great, golden thread of becoming. From an unknowable origin, a universe of pure energy and light was born, expanding and cooling in its first few minutes to forge the simple atoms of hydrogen and helium that would serve as the raw material for everything to come. For hundreds of millions of years, this simple universe drifted in a profound and patient darkness, until the gentle, persistent whisper of gravity could gather these primordial clouds into the first titanic stars. In the fiery hearts of these stars, and in their final, magnificent, explosive breaths, the heavier elements of creation were forged, the carbon, the oxygen, the iron, and seeded back into the cosmos. From this enriched dust, new generations of stars and new planetary systems, including our own, were born. And on this small, rocky world, orbiting a quiet, stable, second-generation star in a peaceful suburb of a vast spiral galaxy, the universe's creative impulse took another, astonishing turn. The Earth cooled, and water condensed upon its surface, forming the first oceans. And in the warm, sunlit waters of these early seas, a new kind of complexity began to emerge. Protected from the harsh radiation of space, the simple cosmic chemistry of carbon atoms, forged in the hearts of long-dead stars, began to arrange itself into long, complex, and self-replicating molecules. The universe, which had already learned to create stars and galaxies, was now learning how to create life. This was not a separate story, but a continuation of the same one. The same fundamental forces that sculpted the galaxies were now at work assembling the first living cells. The same stardust that formed the planets was now providing the building blocks for biology. For billions of years, this life evolved, growing ever more complex and diverse, exploring every possible niche on the planet's surface, in its oceans, and in its air. And eventually, after an immense and patient journey through countless forms and countless generations, a new kind of structure emerged from this living tapestry. A conscious mind. The stardust, through the long, slow and beautiful process of biological evolution, had finally arranged itself into a pattern of such exquisite and intricate complexity that it could begin to be aware of itself and its surroundings. The human brain, with its hundreds of billions of neurons connected by trillions of synapses, is the most complex object we have yet discovered anywhere in the universe. It is a living galaxy of thought and feeling, a biological instrument capable of memory, of imagination, of love, and of wonder. And with the emergence of this instrument, the universe, for the first time that we know of, could begin to look back upon itself. It could build telescopes to gaze at the distant galaxies and see its own history. It could devise theories to understand the forces that had shaped it. It could write music and poetry to express its own breathtaking beauty. This is the most profound and intimate connection of all. Your consciousness, the simple, quiet feeling of being aware in this moment, is not something separate from the universe. It is a feature of the universe. The curiosity you feel, the sense of awe that these ideas might inspire, is not just your own personal feeling. It is the universe's own curiosity, its own sense of awe. We are the sensory organs of the cosmos, the living conduits through which reality has, for a brief and precious moment, become self-aware. Every question we ask about the cosmos is the cosmos asking a question about itself. Every discovery we make is the universe, revealing another part of its own story. And so, your own quiet and personal journey of contemplation tonight has been a cosmic event, a moment in which a small piece of the universe has retraced its own magnificent 13.8 billion year journey, all the way from the beginning to right here, right now. And so, your own quiet mind, resting here on the gentle edge of sleep, is not a small or an isolated thing. It is a vessel of cosmic history, a sanctuary where the universe has come to rest and to know itself. Together, we have taken a long and wondrous journey tonight, a journey that began in the simple, familiar darkness of a quiet room. From here, we drifted out into the cool night air, to see the starlight not as it is, but as it was, a museum of ancient yesterdays. We found our home in the luminous, turning river of the Milky Way, and discovered that our very bodies are made of the ashes of ancient stars that perished long ago. We felt the gentle, unseen hands of the fundamental forces that sculpt our world, and followed the arrow of time back to its source, to a universe that began in a state of perfect and beautiful order. We saw the evidence of this beginning in the gentle hiss of the cosmic background radiation, the oldest light in the universe, a faded photograph of the moment the cosmos first became clear. We journeyed further still, into the fiery furnace of the first 3 minutes, into the speculative, bubbling foam of the Planck era, where time itself dissolves. And we stood at the very edge of our knowledge, at the silent, unknowable point of the beginning. From that origin, we have contemplated the great mysteries that remain, the gentle, invisible ghost of dark matter holding the galaxies together, and the quiet, persistent push of dark energy that is stretching our universe into a vast and lonely future. We have wondered at the incredible fine-tuning of our cosmos, and opened our minds to the possibility that our home might be just one island in an infinite, eternal ocean of other universes. And we have turned our gaze inward, to see reality itself as a kind of story, a beautiful dream encoded in the language of information, a dream that has finally woken up, right here, inside of you. This entire, grand, and sweeping story, from the infinitesimal to the infinite, has led to this single, peaceful moment. And as our journey comes to its gentle close, let us not be troubled by the questions that still remain. The beauty of the cosmos lies not just in what we know, but also in the vast and endless ocean of what we do not. The unanswered questions are not a sign of our failure, but a testament to the universe's magnificent and inexhaustible depth. They are the invitations to future generations to continue this great and peaceful exploration. The vast mystery of the cosmos is not a cold or a frightening thing. It is a source of profound comfort and of peace. To know that you are a small but integral part of something so ancient, so vast, and so beautiful is to know that you are truly at home. The silence of the cosmos is not an empty silence. It is a peaceful, generative silence. The same silence that now cradles you as you prepare for sleep. Let the grand, slow rhythms of the turning galaxies and the expanding universe merge with the slow, gentle rhythm of your own breathing. Allow the quiet wonder of it all to be a soft blanket to wrap yourself in as you let go of the day. Thank you so much for sharing this journey with me tonight. If this story has brought you any sense of peace or wonder, I would be so very grateful if you would leave a gentle thought in the comments, a like, or subscribe to the channel for more soothing stories for sleep. Your kind support is what allows these journeys to continue. And now, I wish you the deepest and most peaceful rest. Drift now into that quiet, unknowable sea of your own consciousness, for you are made of stardust, and the entire universe is dreaming within you. Sleep well.